Yeah, I'm Sinjin Bain. I'm going to talk a little bit about Max Play and what we're doing. We've talked a little bit about initially what our platform is focused on in terms of collaboration, some of the architectural things that we do. But today I wanted to talk more focused on virtual reality, sort of the future in kind of how we see development opportunities and developers working with virtual reality and some of the base level requirements that we all need to think about as we work in virtual reality. And so, just to give a quick background, I know that Mike talked a little bit about us as a company. The leadership team that we assembled is pretty different than traditional game technologists. We have a lot of game technologists, yes. Game producers who've made a lot of games, yes. But we also brought in a lot of engineering and architectural talent from scalable cloud enterprise technologies and companies. So we're a unique amalgamation of game engine people, game pipeline people, and cloud enterprise architecture people. At our core, though, we are game makers, and we are focused on the game industry. These are some of the games that at EA, Maxis, EA Partners that our leadership team has been involved with and led in various ways, whether it's being CTO or executive producer or different features of the company. But what I'm going to talk about is a little bit about what the Max Play GDS platform is at a top level. So we kind of position it as Google Docs for games, and really that's just so that we put a tagline on it. It's more complicated than that because it's not just, word processing. Making games is really complicated, as we all know. But what we are focused on is real-time collaboration. It can be distributed, and distributed means down the hall or across the country or in different countries at the same time, working in the editor, making a game, and being able to preview that game anytime, on any platform, anywhere in the world. So the goal is iteration. How fast can you see how bad your game is, right? And then change it to hopefully make it less bad and eventually end up with a really cool game. Because at least that's what I've found in my experience is it's not usually fun when you start. The goal is to get to the fun by the time you end it. So this is at the top level. The second thing that we really focus on, I talked about it a little bit, is it's incredibly important to be modular and extensible for developers. We talked about it on the panel. It's like developers want to feel like they have control of their development environment, their production environment. Developers need to be able to extend and modify the platform. This is really important. We're all going into VR, right? Some of us may go into VR on a mobile phone. Some of us may go into VR on Oculus, but we're all going to go there, right? Because mobile is VR moving forward. So it's really interesting. Some people will stick with formats they like for the types of games like 2D or whatever, but let's think about VR kind of as a place where we're all going to go, and you need to be able to extend it, because guess what? None of us really understand what good VR experiences are. We just don't. So it's kind of like color desktop publishing after black and white desktop publishing. There's going to be a lot of really crappy VR done by all of us, and then we'll get better, and the goal is to get better really quickly. At the core of all this, to be able to be successful in VR and take advantage and make better, richer, deeper games is having the right runtime technology, and that's what I'm going to talk a little bit about today. We all know and have seen the projections of what's going on with VR and AR. What's interesting is, as developers, virtual reality is kind of the dog right now, but everybody thinks that AR is going to end up being the dog when you look at 2019 and 2020. So in the back of your mind, these are different things. Virtual reality is different than augmented reality. So at least be aware of thinking about what does that mean as a designer or a creative person when I'm thinking about closed virtual environments versus what I may do in my augmented reality creatively, and then roll that back into what does that mean in terms of technology? What do I need? What do I need today? What do I need in a year? And what do I need in 2 years? Because time moves really fast. At least it does for me. So this is what I was talking about a little bit earlier, right? Samsung and Intel and Qualcomm are coming out with 8 and 16 core mobile devices this year. That's a big deal. Guess what? None of the existing runtime technologies actually use or are constructed to use that power. That's a really scary thing to think about, that it's not this hardware that's actually limiting us as developers. It's the software. So let's kind of talk about that a little bit. So in terms of performance, what you really need is something that doesn't have data contention at a runtime, and I'm going to kind of show you what that means. So this is where we are, right? So the hardware is Homer's skull, right? That's your mobile phone with 8 cores in it. And then the little tiny brain is the existing runtime technologies that do not take advantage of the full cavity that we have, meaning the Samsung 8-core phone or the Intel Quad 16 that's coming. These are very powerful machines that you need to make sure that whatever platform you're using takes advantage of it. What that means at a more technical level, and I'm not going to spend too much time, but this is the visual representation. So the current tool sets, the current runtimes, platforms are functionally multi-threaded. What we've done is we've actually created an asynchronous rendering N-core so that we actually have full leverage, not only on graphics. We're not just talking about rendering. We're talking about, and I'm going to show you examples of how this goes, but being able to multi-thread across 7, 8, 32 cores, your simulation, your AI, and you don't even have to think about it. So all of a sudden, instead of what your profiling tool looks like on the left, using current engines, right, where there's this huge spiky performance and some of the cores don't even do anything, this is kind of the way your software runs today on the left. This is what an N-core architecture does. It actually eliminates data contention, no stalling in your pipeline, and it enables you to do more in your game faster when you're in runtime. So what does that mean? How does that look? What's a practical example? So there are some pretty standard tests, stress tests, and we picked this flocking algorithm. So if you think about 10,000 game objects, I mean literal game objects, so what you're going to see is not a particle system, but actually 10,000 polygonal objects that are all calculating the positions of each other and avoiding objects simultaneously. This is what you're going to see. And what it looks like is this. So it kind of looks like a bunch of stars, but those are polygons, cubes, and they're all 10,000 of them, and they're avoiding 8 predators, which is the little yellow with the little yellow dots. And the difference between a 2-core device and a 6-core device goes from 22 frames average to 134 frames a second. So this is what we need to not throw up in VR, right? This is the baseline. You have to have this performance. It's a big deal. So think about that. Just to give you, so for people who get the charts and graphs, when we talked to Intel about what this means, Intel came to us and said, hey, it would be really meaningful to us. This is Brian Bruning and the game DevRel guys. What would be really super cool for us is if you could show us a 25% improvement from 2 to 4 cores and another 25 from 4 to 6, if you can get that. So we put this benchmark test on, and we're actually getting 3-4x performance. So at GDC, we're actually going to show a demo of this tech. So that's level one, that's processing. The second thing that is really important for VR is the ability to have light index deferred lighting. So all of a sudden, what do you want when you're doing sort of a VR experience deeper and richer? Well, I want to have lots of simulation. I want to be able to have lots of density visually in my environment. And I want to have lots of lighting technology, lots of lights available. So LID is something, I think the CryEngine may have it, but it's the ability to basically do unlimited lights. The difference between putting 4 lights on a mesh and 1,300 or 3,000 lights on a mesh for artistic direction is phenomenal. And the other thing that you want to be able to have when you're talking about rendering technology is the ability, so I was talking about the LID, but the ability to actually cull data that you're not using. So you're talking about multi-view rendering when you're talking about VR, but you don't want to render stuff that you don't have to. That's very difficult when you're talking about 2 view frustrums. And then when you're talking about augmented reality, I'll take it one level deeper. Not only do you have to render 2 frames, you have to render multiple depths of light fields. So all of a sudden, what I'm talking about here is VR requires 7x more processing power at a base level to get the same base experience and not throw up. And this is where I was talking about the coherency between views. So the bottom line is, this all comes back to how do we do cool stuff that doesn't get you nauseous? So I'm going to this is light index deferred. You can't hear the audio coming out of the speaker, but that's okay. The narration is what you're seeing, which is very simple, but very profound. You're seeing a mesh, a cube, with 3,000 lights on it. I think Unreal recommends 8, maxing out at 8. So we're not talking about a little bit of difference with this technology. We're talking about massive difference in technology and creativity by new lighting models. So remember those dots? Remember those dots? This is not meant to be pretty. This is technical. What if those dots were birds? And you were in virtual reality, and all of a sudden you had 1,000 birds simulating in real time in your environment at 150 frames a second. Kind of cool. I'm not describing something necessarily that will be a great game, but that's not the point. And the point is, you need the runtime technology to have, see all those little lanterns, those little fuzzy things? Those are individual light sources. There are hundreds of light sources in here casting real-time shadows with full simulation, with every bird calculating where every other bird is in position relative to themselves in real time as a full simulation. This is what NCore and LID does and enables. So that's runtime, VR. That's what we need as an industry. I'm going to back up and go a little bit higher. In terms of, remember I mentioned talking about iteration? So we believe that as an industry, we have a lot of opportunity in VR, and we're actually going to have to work together to solve these problems and find creative solutions. So at the top level, our editing environment is collaborative, and that has a whole bunch of, there's a reason why we can do that. It's because our architecture is not file-based. It's an asset-driven database, and the details of that really I'm not going to get into here. But the point is, as we as an industry strive for new experiences, we need to work together, whether it's as a team or being able to actually see our experience by pushing a button anytime we want, not having to do a build. Like, what if you could look at your game on the 3rd floor and your buddy on the 2nd floor could push a button at the same time, and you could look at changes that you made in real time and you didn't have to pull down a new build? That would be kind of cool. So the goal here is to turn 10, 20-minute build cycles into literally seconds. This is what we believe is what we've been looking for as game developers ourselves. So what we've done is focus on the architectures by which we can enable this sort of behavior as a platform and as a toolkit. The other thing that's really important to us is that we've been lucky enough, because we started from scratch and because we had pretty good architects on our team, is to actually provide a platform that is fully modifiable and extensible. And by that I mean from the UI, which is a service-oriented architecture, all the way down to the runtime. The reality is, with virtual reality, we don't know what you guys are going to need to do and want to do. What we do know is that you want and need a platform that you can modify and insert technologies, whether it's telemetry or whether it's a new audio engine or a physics engine that's appropriate for what you need. You know, 2D is different than 3D. VR is different than 3D. It's incumbent on us to provide the architectures and the abilities for you guys to jump into the platform and the runtime where and when you need. So this is something that's core to us and something that's really going to be important as you explore new platforms. Imagine, I'm not really interested in having 500 programmers developing a code base. What I'm more interested in is providing, and what we're interested in is providing a framework and a core architecture that's well architected top to bottom, that provides X percentage to make a game today. But then what's really going to be cool is, imagine if you could exchange code snippets with 10,000 other developers around the world that may be solving problems that you need to solve. And seamlessly, they've already integrated their tech into the platform, and you can exchange that. So the better we can enable an open platform for the development community on a worldwide basis, the faster the feature set of our platform is going to be developed. And as the new guys on the block, that's a really important business strategy. And I think it'll come back in spades to what we're doing. An example, let me give a practical example of this. We're working with a group called Fingerfood in Vancouver. The Fingerfood dudes are the guys that did the software for the Sphero robot and the BB-8 robot. They're creating a code module, an SDK, a plugin to our engine that will let developers reprogram the Sphero robot. So you'll be able, because of our architecture, to take a toy and be able to reprogram it and create games that you want to be controlling a robot in the real world, so the Toys to Life. That's an example of something that you don't think about as a developer, but if there was the right architecture, you could do something like that, or do an augmented reality experience with a real toy, because you've actually got a code module that somebody's written that's integrated with our platform because of how open it is. These are the cool things that we're trying to enable. So the last point that I think is really important for VR comes back to the premise that I'm not sure we know what it means. And I just wanted to do a couple of examples. And one is eye tracking. So all these devices, whether it's Magic Leap or HoloLens, Vive or whatever, they're all going to have the ability to track your eyes, to know where you're going to look. They're going to track where your hands are. So there's going to be this incredible data available to us as developers. And I have no idea how you're going to want or need to use it. I'm just pretty sure that you're going to have to and you're going to want to, right? So how can you take eye tracking telemetry and incorporate it into your game to modify the game behavior or the AI in real time? And that has profound implications, top to bottom, in the tech stack, right? All the way down to you're going to want to interrupt data in between frames. So you're going to want to be able to have some data insertion or some behavior that changes in between frames that are rendered. And we enable that. We don't know why you're going to need to do it. We just know you're going to need to do it. So this is the kind of thing in terms of new platforms and new experiences that we're really focused on. This is proof that I really don't know, what you're going to need to do. But I do know it's going to be. I do know it's going to be cool. I do know that. No, I don't know. I'm assuming, and my intuition tells me that VR is going to enable all kinds of new games, all kinds of new experiences, all kinds of new interactivity that we haven't thought of before. So I'm kind of excited and interested to see what you all come up with, whether it's on a Samsung 7 that's coming out, this year that has 8 cores, and you're going to be able to do, with the right technology, 90 frames a second, 150 frames a second in a Gear VR or Cardboard or whatever, and experiment all the way up to what's coming with Magic Leap. So that's my little spiel. That's my little talk about kind of what we're all facing with virtual reality and some of the core fundamental technologies, platform architectures, and tools I think that we all are going to need over the next 2 to 5 years.
But let's give it up for Sinjin Bain. Thank you very much.